Okay, Leave Insert Technology 2018, option B, electronics option, is as follows. Okay, it's an op-amp circuit. An incomplete circuit diagram for the control panel of an oil-fired heating system is shown. Light levels from the burner flame are monitored, and a warning LED illuminates if the flame extinguishes. So I've built a circuit here, and we'll just watch it in action working now. So it's actually on now at the moment. Here's our LED to warn us if the flame goes out, and here's our LDR, okay, or a light sensor that will sense the flame light gone out, and then the op amp will start to operate and source its current out to turn on the LED. Okay, so light on it, it's working fine, and then the flame goes out, the light is gone, and now our inputs have changed in our op amp, and our op amp is now sourcing current out. Okay, so it's a safety device or a warning system. Okay, so let's have a look at the other questions within that year. So 2B part 1 says name the input components and give the function of each. Okay, so when they mean the function of each, it's just, are they an input, process, or an output? Okay, and it's the main components. All right, so we don't have to talk about all the resistors. So what we got here, we have our input, our potential dividers. Right, we've got two potential dividers. They're always the input to our circuit, but our main input is definitely the variable resistor and the LDR here. Okay, they are inputs. And then we have a process, okay, and that's our operational amplifier here, and I suppose these resistors are part of the process, because they are providing the limit at what the LDR should trigger, so the op amp is our main process here, and our output is the LDR LED. Sorry, okay, we don't have to mention this resistor, the LED output. Okay, so that's a nice handy one for 6 marks. Describe the operation of the circuit. Okay, so the basic principle of the circuit is to compare the voltages at the op amp. Okay, so when the voltage changes, all right, our op amp starts to source out current and turn on the LED. The potential divider here and here provides the reference voltage at which to do that. Okay, and our main input here, this potential divider here, provides the circuit with the voltage from this part feeding into the op amp. Okay, so let's just watch it again. All right, so yeah, at this point here, everything's working fine, and we have a voltage of 1.3 volts. They're going into the non-inverting input of our op amp. And here we have a voltage of 3.56 volts. Okay, so when our voltage here goes higher, then our LED will come on. Okay, so the resistance in our LDR is changing. Oh, the light is gone, the flame has gone out, and we now have a voltage of 4.2. Okay, and now the op amp is sourcing the current out like this. Okay, now I think what would have been really good in this exam would have been to use another LED to say that everything is okay. A green LED in there would have been better, because we could have explained or talked about the op amp as a flip-flop circuit. Right. Okay, so I'm going to put in a resistor and an LED here. Let's connect them now. I need to connect my LED in there before this resistor. Like that. And now, see. Obviously the system is broke here. Okay, needs to be repaired. And now it's working fine. And we can see our operational amplifier, the voltages are fluctuating between the non-inverting and the inverting inputs, and our output is sourcing current in and sinking current out. And that's how an operational amplifier works. Okay, so I think 2 outputs would have been better for that one. And in part 3, it says redraw the circuit to include a relay which controls a 220 volt oil pump. Okay, and for that, remember the transistor circuit at junior cert with a relay? That's what I would put on there. Okay, so I would get rid of the LEDs, connect a wire across, connect a wire like this, and bring your relay back around here, and then write 220 here, draw your relay and a motor, and that would be your pump on all the time, pumping the oil when it's needed. Yeah, that's the whole thing there worked out now. If you can't remember what a relay looks like, okay, because they are a little bit complicated, remember there's a coil and a magnet and a switch. All right. And if you can't remember that, just draw a little box and write relay inside it. Just don't forget to put in your voltages and your ground voltage and your motor. Okay,